So we finished our camber measurement on this vehicle. The right rear had a little more camber, negative camber, than the left, but we're not going to adjust it right now. When we actually put 200 pounds of weight in the driver's seat, because we did our camber first with no weight in the driver's seat, we put 200 pounds of weight in the driver's seat, increased the front camber by a little, same side to side. It went from about negative 2.2 to negative 2.4. The left rear had a little more negative camber by about 1/10 of a degree, and the right rear lost a little by 1/10 of a degree. So not enough right now to change. In order to do it on a McLaren, to take negative camber out, you've got to take apart the upper control arm and move an eccentric to take it out. If you wanted to add camber, you can actually shim the lower control arms with some shims. We use the ones that come standard on C6 and C7 Corvettes. The upper control arms on those cars in the front and the back are shimmed from GM, and these are precision shims. I forget the dimension. I'd have to measure some. They're about I think 1.2 millimeters or something. I forget what it changes. Anyway, we're going to leave it alone for right now. The car drives fine. Tow was as we set it before, so it was in spec. Thrust angle, and we actually use lasers to do the thrust angle and set the tow front to rear. We use tape measures on the tow bars to set tow. You can see that there's a laser pointing at a target on either side, and that's what we use to do thrust angle. This car, front to rear, was within about an 1/8 of an inch on the target. Not enough to fool with. Not sure on the target, and I'll have to check with the supplier on this grid based on the distance of the wheelbase. I would say an 1/8 of an inch off side to side on the target is probably not much. It's probably an infinitesimal amount, so we're not going to fool with it. The car drives fine. There's no uneven tire wear. Again, lasers on the other side. You can see the target there that we use to be able to set tow. We did the tow first, set the lasers. You then move the lasers to the rear, targets to the front, and that's how you check the alignment. There's magnets on the tow bars, so the tape measures stay in place while you're doing this. So basically, pleased with the overall. We're not going to do caster right now. Caster requires some turning plates, which I'd have to put underneath the front hub plates to be able to turn the wheel 20 degrees either side and measure that way. Caster's hard to adjust on this car unless you want to start shimming the lower control arms, and then you start fooling with camber. So when we had it on the Precision Hunter machine, the caster was about 4.8 on one side, positive caster, and about 5.0 on the other side. That's 2/10 of a degree. That's close. You're really not going to feel it driving the car. If you start getting into things like 4 degrees of positive camber on one side and 6 degrees on the other, then you start looking into what's going on. This car runs less. Some of the Corvettes, the late model Corvettes, run as much as 6, 7, 8 degrees of positive caster. So anyway, that's basically how you align the car and set it up. The lasers are a big help versus the old system of using a string strung down the side of the car and trying to get them even side to side. With this system, with the tow plates, the tow bars, the targets, the precision laser, and these lasers are very precision. They have rechargeable batteries in them. They have a precision bracket. It's all designed to bolt on and shoot side to side. The batteries in it are lithium ion rechargeable, and they do come with a recharger, so you can recharge your batteries. So overall, very pleased. Now we're going to disassemble all this and start on brake pad replacement, which will be a separate video, so stay tuned.